And welcome back, everyone. You can see my annoying autosave prompt has come back up, so I'll save my part. And we're going to go ahead and jump right into getting this material removed from the pocket here. So before we jump into that, we want to go to our Toolpath Manager, and you'll notice here this red arrow. So that red arrow denotes where you're going to insert a new toolpath. So if I go ahead and create a pocket toolpath here, it's actually going to insert that pocket toolpath in between these two contours. And I don't want that. I want that to be after. So I can move this up manually here with these two arrows. Move that arrow wherever I want, or I can click Position Insert Arrow after selected operation or after selected group. So I've got this selected here, contour. If I click that, it's going to drop that right below. So you just always want to be mindful of where that red arrow is, especially if you're copy and pasting toolpaths, it might shift on you. Another way you can create a toolpath here instead of going up here is if you're in your Toolpath Manager, you can right click, and that's going to bring up a context menu quite extensively actually. And you have a bunch of mill toolpaths. If I'm in a hurry, sometimes I'll do this method. But for the sake of doing this, we'll go ahead and use our drop down. So back in the old days, I should say old, but relatively recently, the standard way to approach a pocket such as this was with a standard pocket toolpath. And a standard pocket toolpath is going to enter into the pocket and basically create a number of overlapping paths that come in here and cut this shape and remove all that material. Those are really useful, but when you come into an area like a corner here, you're going to be overloading that tool because it's cutting a really big angle of engagement. So programmers and developers have come up with a new type of toolpath known by various names. In Mastercam, it's called dynamic milling. In Fusion 360, it's called adaptive roughing. So it's a really useful toolpath, and it has a lot of control. And what it does is it peels away material. So even when you get into a corner, you're still maintaining a constant tool engagement. So you're not going to overload your tool, potentially breaking the tool, and it generally leads to a bit longer tool life, which is really useful. So that toolpath type relies on variable width cuts. So instead of doing depth cuts, it's actually taking advantage of the width cuts, such as those multi-passes which I talked about. So in order to create a dynamic toolpath for this pocket here, we'll go and do dynamic mill here. If it's not showing up, you can click drop down. Do not want to do dynamic contour, that's a finishing operation. So we'll do dynamic mill, utilize the entire length of the cutting tool to efficiently mill pockets, etc. So we'll go ahead and click that. The chaining here is slightly more advanced, because you can choose machining regions, how you want it to machine. So in this case, we obviously want to stay inside of the pocket geometry. You can also create some avoidance regions, air regions, containment regions. We're not going to need that right now, but it's very useful to have those options available. So we'll go ahead and choose a machining region, and our machining region is just this pocket here. Now, Mastercam's dynamic milling is advanced enough to know that no matter which direction you select your chain in, it's going to do climb cutting no matter what. So there's no need to reverse this chain here in a dynamic mill or even a regular pocket toolpath. So again, I don't really even use standard pocket anymore. I find the dynamic mill toolpath, I just think it's a little more feature rich and leads to better tool life. So we'll OK that, and we'll OK out of our chaining options, and we're back into our cut parameter screen. So you can see how that sort of peel milling action is going to work. You can see the motion there in that descriptive view there. So let's go ahead and we'll select our tool. In this case, we're roughing out this pocket, and we're going to use that same 1/2" end mill. You generally you want to use the biggest tool for the job, and a 1/2" end mill will get in and cut most of that material out. Now, these radii here are actually smaller than the diameter of that 1/2" tool, so we're going to have to come in with another smaller tool to finish that up. So 1/2" end mill. You want to go to cut parameters here. Now mine is defaulted to 15% step over, and that's how much of a width cut are you going to take. The percentage value represents how much of the diameter of the tool you've selected. So 15% of a 1/2" diameter end mill is 0.075 or 75 thousandths of an inch. So we'll leave 15%. That's a pretty good standard step over for aluminum that I use. And stock to leave. So you want to leave a little bit of stock on both the walls and the floor, because we are going to come back in and give it a finish pass, and it's going to make it look really nice and really good. So yours will default at 50 thou. That's a little bit large in my opinion, so I like to leave about 0.01 inches or 10 thousandths of an inch for an aluminum finishing job. Corner pre-treatment, a couple other options available for this style of toolpath that we don't need to worry about. Now, if you did have a pocket that was like 3 inches deep, obviously you're not going to want to cut that whole depth at once, so you can definitely add depth cuts for a deep pocket. But because that pocket's pretty shallow, we're going to go ahead and not bother with depth cuts at all. Entry motion here is a relevant thing to consider. So how is that going to enter in? If you think you have a solid block here, just plunging straight down into that material isn't good for the tool, and it's probably going to clog the tool and break it. So Mastercam defaults to a helical entry, and you can see here that's basically the tool spiraling into the material, and the radius of that is set to the radius of the tool, which is 1/4 inch. So we'll set that to a 1/4 inch radius for the helix. Again, ignoring breakthrough altogether, we'll go into our linking parameters and we'll set the depth of our tool path. So our retract here and our feed planes are all set. Those are good. Top of stock set to 0, and we'll go ahead and choose our depth here. So we know we're going to go to the bottom of this pocket, which apparently is a 1/2 inch deep, and we'll click OK. You can see our tool path here is kind of funky. I don't know why it did what it's doing. So that red motion there is the entry motion, and instead of helixing, it's actually kind of spiraling on a profile for whatever reason. Let me see if I can get that to do what I want. So if I change my entry motion and maybe a smaller radius there at 0.2, let's see. There we go. That's what we're looking for. So you'll need to change that helix radius so it's a little smaller. And now you can see the entry motion is that red spiral there. So we'll go ahead and backplot this, and as I step through this, I'll slow my speed down just a bit, and we'll play through, maybe speed that up a bit. You can see a nice smooth helical entry for our tool. And as it gets down, you can see those small cutting overlaps, and you'll see it's kind of peeling away the material, which is really good for tool life. Again, It's distributing the force of the cut along the whole length of the tool, as opposed to a standard pocketing toolpath where you might only be cutting at the tip of the tool, maybe a 1/4 inch deep. Another great thing about this toolpath is that you can run extremely fast feed rates. So whereas with a standard pocket I might run a 1/2 inch end mill at 50 inches per minute as a feed rate, with a 1/2 inch end mill in this case, I would probably be running this toolpath at 200 or more inches per minute. So it removes all of that material quite quickly. So that toolpath looks great. Now, one problem with that is that it's going to leave that spiraling pattern all over the floor of our pocket, as well as the walls are going to have a bunch of vertical striations all along it. So that's why we left a little bit of stock to finish those up. So with the floor here, the method I use is I just copy and paste this. So I'll right click, hold, and drag this down and copy that after there. And all I'm going to do is go back into my parameters, and I'm going to turn off floor stock to leave. And I'm actually going to turn my step over percentage way up to 85%. And that's going to leave a much better finish on the floor there. Still leaving 10 thousandths on the wall to finish it up. And I'm being a bad example, but we want to make sure to label these. Finish the pocket floor. And I'll go into my original here and I'll say rough the main pocket. Contours are good, and we'll face the part. So let's go ahead, regenerate our floor finish here. And now you can see a much wider step over. That's going to leave a nice clean surface finish on the bottom of the part. Now, because all this material is removed initially, we don't really need to spiral this high up. That's just cutting air. So if I go into my linking parameters here, and I can tell it that the top of stock is actually the bottom of this pocket now, regenerate, and we can see the tool starts much lower, so we're saving a bit of time there. So we finished the floor here. Now we haven't finished the wall, and if we look here, let's measure our radius here, and we'll right click and analyze the entity. Analyze entity properties. So all these radii are 0.195, and we are coming in with a 1/2 inch diameter tool which has a 1/4 inch radius, meaning we need to come in with a smaller tool to finish that up. So let's bring our arrow down, and we'll go in and create a contour, simple contour to finish the walls. We will select that chain. Again, in the contour case, we need to make sure we're going counterclockwise there, because we're on the inside. And we need to select a tool that can fit in a 0.19 inch radius. 3/8 tool is going to leave 0.1875, so let's go ahead and use a 3/8 flat end mill. Comment here, finish the pocket walls. Cut parameters. Again, all of this is good. We don't need to worry about that. No depth cuts necessary on a finishing pass. Lead in, lead out. You'll notice enter and exit at midpoint and close contours is unchecked. That's because, as a default, Mastercam brings in all of the parameters from a previous contour operation. So any previous type of toolpath of the same type is going to bring in whatever parameters you had in. So that's something to keep in mind. Slightly annoying sometimes. You can definitely turn that off, but I like to have it on. In the case of this internal pocket, we kind of want that to enter at the midpoint on a closed contour, so we'll turn that back on. No multi-passes or anything. Linking parameters again, let's go ahead and just set the depth on that point there, and we'll OK that. So now we see a nice clean contour. Save. Let's run through Backplot, and I'm actually going to use the S key, stepping through. So I go and I'm in this corner here. Let's go to a top view, zoom in a bit, and you can see now that that 3/8 end mill is able to clean up all of that material. And that is just what we want, so that's great. So we've finished our pocket completely. Let's move on, and we can cut this open pocket.